Hello everyone. Our engineering exploration course project was to make a laddu making machine. Our team consists of 4 members. I am Sushmita. My teammates are Sakshi, Ajay and Supreet. We are working under the guidance of Ashwin sir. Problem definition. It is the description of the requirements of the customer. Here the requirements are as follows. The laddu making machine should be semi-automatic, the machine should be safe, and it should be hygienic as we are preparing laddus. It should be as compact as possible and portable. The machine should make 2 to 4 laddus simultaneously. The laddu should have a diameter of about 4 cm. The machine should be ready in about 3 months and the budget is 5000 rupees. The machine should have a container to store the laddu dough, a shaping unit to shape the laddu, and a collecting unit to collect the laddus. Function tree and function clustering. Laddu making machine has 3 functions: storage, shaping and casing. The subsystems identified are the storage subsystem, shaping subsystem and the casing. In storage subsystem, the dough is stored in a container. It is pushed to the shaping subsystem with the help of a screw feeder. In the shaping subsystem, the laddus are shaped with the help of screw feeder. Then the laddus are sent to the container. Casing subsystem, it has all the required components. The generated concepts are as follow. Storage subsystem, this is the shaping subsystem and this is casing. In the storage subsystem, the dough is stored in this container. It is moved to the shaping unit with the help of the screw feeder through the pipe. Here, the 3 screw feeders are placed in a triangular form to shape the dough. The laddus are shaped here and they are collected in this container.
So this is the 3D model for the whole system. Firstly, the storage subsystem houses the dough and pushes it out using a feed screw which is placed inside the container and the motor is placed here. Once the cylindrical dough is pushed out of the storage subsystem, it moves into the shaping subsystem. The shaping subsystem contains 3 feed screws in a triangular fashion and connected through gears so that they can be rotated simultaneously. The cylindrical dough enters into the middle of the 3 feed screws so that it can be shaped into a sphere. The rotation of the 3 feed screws is such that the dough is shaped into smaller spheres, which is practically a laddu. Finally, the sphere or the laddu falls into a inclined plane which leads to a container, cylindrical container, which is the casing. This is the final storage of the laddu.
This is the circuit diagram of our entire system. Here we have used the 2 DC motors. One motor is for pushing the dough and the other one is for shaping the laddu. You can also see a sensor which is used for counting of the laddus in there. It is the Simulink model of the entire system. Here 2 of the motors are made connection with the Arduino and they will run with the help of the battery. Although there is a sensor connected to the Arduino. And we have to look at the bill of materials required for the entire system. We are using the 5 GI sheets of area 625 centimeter square and it costs around 250 rupees per sheet. 2 of the DC motors which will cost around 400 rupees and feed screw which are 4 in number and costs rupees 500 per one. Acrylic rod costs rupees 300 per feet in length and mainly we require Arduino Mega 2650 which costs about rupees 890.
Motor sizing and battery sizing of the entire system. For subsystem 1, the density of GI sheet is 7.85 grams per centimeter cube. The diameter of the feed screw is 5 centimeters and the length is 10 centimeter. So the volume is 157.1 centimeter cube. From this, the calculated mass is 1.233 kgs and the torque is 0.6165 Newton meters. So the required DC motor for subsystem 1 is 150 rpm DC motor and the battery is 9.68 watt battery. So for the subsystem 2, the density of GI sheet used is 7.85 grams per centimeter cube and the diameter of the feed screw is 2 centimeter and the length is 6 centimeter. So the volume is 75.3982 centimeter cubes. So the mass which we have calculated is 0.5919 kgs and the torque is 0.0710 Newton meters. So the DC motor required for the subsystem 2 is 1000 rpm DC motor and the battery is 7.44 watt battery. Functional specifications of the entire system. The first function of our laddu making machine is container to store dough, and its specifications are: as a part of subsystem there will be a hopper to store dough and a screw feeder to push the dough. The second function is shaping, and its specifications: 3 screw feeders are arranged in a particular order to shape the dough and make laddus. The third function is counting number of laddus. An IR sensor is placed near the container that collects dough to count the number of laddus get prepared. And the fourth and the last function of our laddu making machine is container to collect the laddus. A container is placed below the shaping subsystem to collect the laddus. This is the simulation for our course project, that is a laddu making machine. Here we are using the 2 DC motors and 1 IR sensor. So let's have a look on this. Here we have used the 2 DC motors. The first DC motor is for the feed screw placed inside the storing container to push it towards the shaping platform. This is the second DC motor. This is we are using for the shaping purpose. This is the IR sensor, is for counting the number of laddus as it gets started. So I will start it. As you can observe here, the first DC motor starts to rotating. In the same way, the second DC motor is also started to rotate. So let me show you the code here and look at the serial monitor. So I will clear this. So you have a look on the serial monitor as it is giving me count as a 0. So to make it operate, I have used the IR remote. So I will first clear this and I I will start the IR remote. So as I started this, you can observe it is giving me the count. For this project, let me call it as a count of laddus. So it is giving me the count of the laddus which get displayed on the serial monitor. So I will stop this. So as you can observe, both the DC motors will start to rotate at a time, and the IR sensor giving me the count of the laddus, where it is giving me from 0 to till whatever the count of the laddus. As you can observe, it gave me up to the 21 count.